OpenAI just launched an AI that generates code at over 1,000 tokens per second on a dedicated chip that's 57 times larger than NVIDIA's H100. This is GPT 5.3 Codex Spark, the fastest coding AI ever built, and it runs on hardware that changes everything about how AI inference works. But Spark didn't come out of nowhere. It's built on GPT 5.3 Codex, a model with a unique origin story. During its own training, Codex helped debug the process. It managed its deployment pipeline. It diagnosed its own test failures. Sam Altman confirmed it. Using Codex to build Codex made the team ship dramatically faster. This is the first time in AI history that a model actively participated in its own development cycle. Debug, deploy, diagnose. Three capabilities that turned a coding model into a self-improving system, 25% faster than its predecessor. And the results speak for themselves. On SWE-Bench Pro, Codex set a new all-time record. On Terminal Bench 2.0, it jumped from 64% to 77.3%. That's a 13-point leap over the previous generation. On OS World Verified, it gained 26.5 points, and it runs 25% faster than GPT 5.2 Codex across the board. There's a serious side to this power. According to OpenAI's own system card, GPT 5.3 Codex is the first model in the company's history to receive a high classification for cybersecurity. Certain high-risk queries are automatically rerouted from Codex to the older GPT 5.2 as a safety measure. OpenAI is being transparent about the risk. This model is powerful enough to warrant new guardrails. Now, enter Spark. OpenAI took Codex and deployed it on the Cerebras WSE-3, the largest chip ever built. 4 trillion transistors, 900,000 AI cores, 125 petaflops of raw compute, 44 gigabytes of on-chip memory, all etched on a single 5-nanometer wafer. That's 57 times the size of NVIDIA's H100. Imagine fitting all of Wikipedia into the chip's cache memory without ever touching external RAM. This is the first time OpenAI runs a production model on non-NVIDIA hardware, and the results are staggering. Spark generates code at over 1,000 tokens per second. That's 15 times faster than the standard Codex model. OpenAI rewrote key parts of their inference stack to make it happen. 80% less overhead per round trip, 30% less per token, and time to first token cut in half. You can watch Spark write code in real time. It's like watching a human developer type, except it never stops. But here's the trade-off. On Terminal Bench 2.0, Spark scores 58.4%, compared to 77.3% for the full Codex. That's a 19-point drop in accuracy for a 15x speed boost. The question becomes, when is raw speed worth more than precision? The timing is no accident. Spark launched the same day as Google's Gemini Deep Think. 1 week earlier, Anthropic dropped Claude Opus 4.6 on the same day as GPT 5.3 Codex. And behind it all, a $10 billion deal between OpenAI and Cerebras, signed in January, with plans to scale to 750 megawatts of compute by 2028. The AI hardware race just became a three-way war. So what does this mean for the average developer? Real-time AI coding is here. Spark can write, debug, and iterate at a speed that matches human typing. But right now, it's only available to ChatGPT Pro subscribers through the Codex app, CLI, or VS Code. No public API yet, no local deployment. This is a research preview, the first of a planned family of ultra-fast models. OpenAI is betting that the future of AI isn't just smarter models, it's faster ones, running on purpose-built silicon. Let's recap. GPT 5.3 Codex debugged its own training, a first in AI history. Then, OpenAI put it on the largest chip ever built and created Spark, 1,000 tokens per second, 15 times the standard speed. The accuracy trade-off is real, But so is the paradigm shift. AI performance now depends on the hardware, not just the model. The question is, what happens when speed and accuracy converge? I'm preparing a full Spark vs. Opus 4.6 benchmark on real code next week. Subscribe so you don't miss the results. See you in the next one.